We'll see which one it is. I'm going to wander. So is my mic on so I can wander? Good. OK. Well, welcome, everybody. Thank you so much. It's a pleasure to be here. Again, my name is Kerdok. I'm a clinical development engineer with Intuitive Surgical. I've been with the company for 8 years now, a little over 8 years. And I'm here to talk about robotics and MedTech. And before I get started, how many of you are actually in the medical field or medical technology company? OK, good. A good chunk of you. Great. OK. I'm happy to take questions throughout, but I guess there's a Q&A at the end. But I'll try to explain things as I go here. When I was asked to give this talk on medicine and technology and the intersection of medicine and technology, I did what most people do, and I Googled, what is medicine and technology? Because I just wanted to see what came about. And you know what came to mind, or what came out, is probably what you all are coming to mind on the present day wonders. You've got wearables, you've got surgical robotics came up. I was happy about that. Med devices, digital medicine, you name it, you get this kind of picturesque of these like sort of futuristic things from prosthetics, and I don't even know what she's doing, but like you get this idea of these real future kind of like, wow, we're at this moment now, right here in Silicon Valley. This is where medicine's meeting technology. And in reality, my clicker didn't work. It's been around for a really long time. This is actually a picture of one of the first recorded types of surgeries. It's called trepanation. And yes, they're drilling a hole in a man's head. This is a procedure that was done to relieve headaches or get evil spirits out of your body. And this was done in the ancient times with flintstone, literally, as a tool. But they wouldn't have been able to do that procedure without the tool, without the stone. Then 3000 BC, the ancient Egyptians and Hindus figured out how to make things out of copper and steel, and the tools got to develop. And this picture is actually more like, I think maybe 1200 BC, when they were starting to figure out gears and things like that. But my point is that the intersection of medicine and technology has been around for a really long time. And I actually don't think it's an intersection at all. I like to think of it as this continuum, okay? That one completely affects the other. You can't have one without the other. That there's a balance with medicine and technology. And in fact, the other day I was working with a surgeon and showing them a new feature of our product and telling them how we designed it and what we designed it for and what we think the clinical application is and so forth. And she said to me, oh, well, that's great, and I'm going to use it for that, and I want to use it for this. And so what I really like to think about in this continuum is impacting techniques and in order to expand applications. So it's this continuous thing, because right after she said that, I was like, oh, well, if you're going to use it for that, then I'm going to want to tweak the technology this way. And you can kind of see how this circle is constantly evolving, where we are identifying needs and meeting them with technology and vice versa. And this really is what Intuitive Surgical is all about. And that same surgeon said to me, and she didn't remember where she had heard this quote from, but I've heard something similar to this before, which is the surgery of tomorrow will not be built on the technology of the past. And that's true. We don't drill giant holes in people's heads with barbaric-looking machines anymore. But we iterate and we impact technique and expand clinical applications. So our goal at Intuitive is to improve patient outcomes, to improve the patient quality of care, and get people back to life, back to their active lives as soon as possible. So who are we? Well, we're the global leader in robotic-assisted minimally invasive surgery. That is a mouthful. But we were started in 1995, and this is something that actually a lot of people don't know about, that surgical robotics has been around for 20 years, and that our company's been around for 20 years. And we launched our first robot, and that's a picture of her up there, right there, the Da Vinci, in 1999. Now, for those of you in product development, 4 years between the start of the company and launching a massive capital equipment, plus all the instrumentation, software, vision system, testing, manufacturing, getting customers, because this is like a paradigm shift in surgery. Before this, people were using chopsticks through little holes, and now we're saying, hey, actually try to use this big robot. And performing on patients within 4 years is a pretty phenomenal feat. And the other thing I want to point out is that this robot up here, first used in humans 16 years ago, is still operating on humans today. So we've obviously evolved since then, and I'll get to that in a minute. But think about a technology that you used, even whether or not you influenced it or not, 16 years ago. And is it still in use? Would you still trust it to do precise surgery on somebody? I'm always really impressed by that figure. And it takes a village to make these things work and to function as well as they do. We're growing. We've been growing constantly, and we're currently at about 3,000 dedicated employees. And that's engineering, sales, support, manufacturing, and we're worldwide. We have offices, our headquarters are here in Silicon Valley in Sunnyvale, including our manufacturing facility, which we're very proud about, that we manufacture our robots here in the US. We also have offices in Georgia, Connecticut, Mexico, Switzerland, Japan, China, and Korea. So we're definitely a global company. And I want to iterate on what our goal is, that our vision, and this is actually on the back of all of our business cards. And I love it because it's taking surgery beyond the limits of the human hands. And you're going to hear me say that throughout. So many of you, when you walked in, you saw my baby, the XI, in the foyer or whatever that area is called. But so I'm going to talk a little bit about what is the system. And the picture here is our latest robot. It's called the Da Vinci Xi. So some people get confused. They're like, oh, is your robot Da Vinci and your company Intuitive? Yes, that's how it works. So the company is Intuitive. The product is Da Vinci. And we have 4 different platforms. Our latest one is this one. It's the Da Vinci Xi. And it's a surgical system. It's controlled by the surgeon. And it facilitates minimally invasive surgery. And I'm going to get into a lot of detail about what this system is and is not in the next few slides. But one of the things that it's not is there's a big misconception out there that when you say robotic surgery, or robotic-assisted surgery, people think that Rosie Jetson is about to pop out and do your surgery for you. And that's not it at all. The robot is an extension of the surgeon's hands. And it's funny because I had a picture up here initially with like Inspector Gadget, because it's really, it's an extension of the surgeon. And we increase the surgeon's capabilities because we're giving them this really awesome, precise tool. But it's still the surgeon is the one making the decision. The surgeon is doing the surgery. The robot is just a tool. So similar to the NASA arm where somebody is moving it with a joystick somewhere safe inside, it's the same thing with the robot. And some of the capabilities and I'll get into this in more detail in a minute, but we can we scale motion, we can do tremor filtration. We really have a platform for allowing really precise movements, again, extending the capabilities of the human hand. So the core system technologies that we base our product on evolve around vision, dexterity. Whoops, I skipped a page. I'm old school. I have like handwritten notes here. I'm watching all these tweets pop up all around here, and I'm like, whoa. I got my pen and paper over here that I need to refer to. But so our core values are around basically vision, precision, dexterity. And when you go demo the robot, which I really hope you guys all get an opportunity to sit down and drive the robot and see the vision and experience how intuitive it is, our first core system technology is intuitive motion. And it's kind of really hard to talk about our robot or to demo it and not use the word intuitive, because that is probably the #1 thing that we're trying to achieve. And what I mean by that, and for those of you that are familiar with robotics works on a master-slave type of situation. So whatever I do over here on the master, the robot's going to mimic my motions over here. And it's the same thing. That's what we mean by intuitive motion. In laparoscopic surgery, you are basically, you have straight sticks, is what a lot of people call it, going through ports, and you're kind of operating in the opposite. Left is right, right is left. You have a fulcrum effect. And you're looking at things in 2-dimensional vision in an area not where you're actually operating. So laparoscopic surgery, is sort of the opposite of intuitive motion. Where here, we can use a computer to remap the surgeon's motions to exactly happen at the instrumentation. Because it's our goal to basically make the system as natural as possible. You want the surgeon to have an experience as if they're doing open surgery, but they're doing it in a minimally invasive way. So how do we do that? Another core system technology is through our wristed instrumentation. It's as if the surgeon's hands are literally inside the patient moving around, but they're going through holes that are maybe 8 millimeters big instead of a very large incision. We have a whole suite of instruments too. And then the other thing that kind of makes it what it is this amazing visualization that we have. We have 3D HD vision. And what you can see behind me here is a picture of the endoscope. And what you'll notice is that there's 2 channels. Well, we're humans, we have 2 eyes. So we have 2 cameras on every one of our endoscopes. Those 2 cameras go to 2 LCD displays in what this is called the surgeon console. And so when you sit down and you put your head in the console, you have this immersive visual experience. How many of you have seen the movie Inner Space? The slightly older people in the crowd know what I'm talking about. It's a Kevin Spacey movie where literally he gets miniaturized and gets shot into somebody's body, and he's driving around inside the vessels. And this is what I always feel like when I'm operating on the system, is like when I'm operating on the mitral valve, like I am the mitral valve. Like it is everywhere around me and my instruments are there. Our visualization is really quite incredible. And again, it's a core system technology. And lastly, it's ergonomic. You can see the surgeon sitting down. You're no longer standing up. You're no longer fighting against the obese population and trying to manipulate their body walls and so forth. You're sitting down. Surgeons can do more procedures in a day. Surgeons can operate later into their careers. We filter their tremors. So there's filtering of the motion, and there's also scaling of the motion. So I can comfortably move. I can tie a very, very, very tiny little knot, but I can do it in a big way, right? It's kind of like when you learn to tie your shoes and you have the big giant string, and it's the same kind of idea. And so these are the core system technologies that make up the robot. And together is basically what the Da Vinci system is. And what I'm going to show here is the 3 core components of the system. We start with the surgeon console, which I've already talked a little bit about. That's where the masters are. That's where the surgeon operates. You could think of it like the video game console. This is kind of where the action's at. And it's ergonomic. There's motion scaling. It's where you get your 3D visualization. Then you have the actual robot itself, or what we call it as the patient side cart. And this picture is the picture of the XI system, our latest, and that's the one that's out in the lobby. We launched this in April of 2014, so it's just over a year old. And the unique stuff about this robot, which I'll get into in a later slide, is that it's boom mounted. So the robot sort of starts in this position, and it can position itself so that it's out of the way, so that you have 270-degree access to the patient at all times with this new system. And it has universal arms, which is also really important because it gives the surgeons lots of flexibility. You can put an instrument on any arm. There's 4 arms. And you can put an instrument on any arm. You can put an endoscope in any arm. You can change it midway through the procedure if you want a different vantage point, or if you're operating with 2 left hands or 2 right hands. I'll get into the arms in a little bit. But that's the patient side cart. So that's really the tool. That's the robot that's holding the instruments. There's cannulas inside the body wall, and that's your entry point into the patient. And then lastly is the vision cart, or the brains basically of the whole system. And this is where everybody else in the operating room can kind of see what's going on. We pipe the surgeon's view onto that monitor that you see there. We have telestrations, so if you're teaching or you want to say, hey, what's this? And you can circle things and the surgeon can see your message. So that's really at the bedside. And the unique thing on the XI system is that we've really made this great modular platform, so everything's really integrated. I actually don't know what the X stands for in Da Vinci Xi. I think it was because marketing couldn't come up with a better name, but I means integrated. Engineering had a lot of really great names for the system, but they weren't accepted. And one of the things that's integrated is this guided setup. We actually tell people how to set the system up properly and to optimize its setup so that you can have a really trouble-free procedure. And then the other integrated part is that we've actually included the electrical surgical unit, which is the unit that delivers energy to the instruments, or a different advanced functionality to some of our other instruments. All that's integrated into the system. So now we know if I'm docked to the cannula, what instrument's on, is that instrument connected to what energy and so forth. So we have a complete closed loop of control of everything, and that surgeon has that control at the console. I didn't point out there's pedals here. It's really like playing an organ, but a lot easier. You've got some energy pedals that activate the functions of the instruments. You've got some functions that control the robot itself. And then we try to make it so that the surgeon doesn't have to ever take their head out of the console, and so that they have everything right there at their finger or footsteps. So this is our latest and greatest. We didn't obviously start there. And this is a quote that I like that talks about progress. and that progress has not followed a straight ascending line, but a spiral with rhythms of progress and retrogression, of evolution and dissolution. I just thought that was a cool quote. And it's true because really, a lot of things kind of have to come together, and you have to have a lot of failures before you can sort of get to the type of product that we're ready and that we feel comfortable putting into a patient. And so the history of Da Vinci is no different, and it really is a collaborative effort and sort of a lot of things happening at the right time at the same time. And you may not think of this way, but in the 80s, which hopefully most of you remember, there was the invention, if you will, of the personal video camcorder. Okay, you remember these? They were actually quite large. But the ability to miniaturize a video signal actually is what was the birth of laparoscopic surgery, because now we could see inside the body without having to expose the whole body. And that launched a paradigm shift in all of surgery. And most of you that work in MedTech probably work in minimally invasive technologies, because this just opened and exploded a whole field of there's a huge need now. We have to miniaturize everything and get it through these little holes because now we can actually see inside. And robotic surgery was no different. In the 80s, DARPA basically decided that it would be safer to have surgeons safely away, and maybe we can use telemedicine and robots to operate on soldiers in the battlefield. That was literally the start of robotic surgery. Then SRI figured out telepresence, and IBM, remote center technology, MIT with frictionless or low friction manipulators. All of those things came together, and it was like, hey, there's a product that can be commercialized here. This can go to the benefit of everybody's hospitals and procedures, and we don't have to just put this on the battlefield. And that's where Intuitive came about. And we licensed the technology for these three things, and we came out with our first robot in 1999, which we now call the Da Vinci Standard. And I don't know if that font you can read, but actually the first robot that came out was three arms. So one arm was dedicated and it held your endoscope, and then you had your two operating arms, because we kind of design things in an anthropomorphic style, and we have two arms and eyes. But really in 2003, we added the fourth arm, and that's where things took off. Because when you're doing surgery, you need that other arm to sort of retract something out of the way, and then you can have your two active arms. So we started being able to give more autonomy to surgeons. Surgeons love autonomy and love being in control. And once we kind of were able to give that to them with a set of instruments, they were really able to start doing more complicated procedures that couldn't be done with that straight stick laparoscopic technology that I was talking about. And then in 2006, we evolved and we launched our Da Vinci S system, which stood for streamlined. And the S system really improved our visualization. We were able to introduce HD in a robotic platform for the first time. And we introduced this thing called TilePro. Similar to what Vocera was saying, you know, the surgeon wants a lot of different points of information at the same time. And what TilePro allowed us to do was pipe in patient vitals if they wanted to see that, or imaging. And so they kind of had a picture-in-picture experience of what they were working on, and then any other information that they wanted to pipe in. In addition to that, we changed, obviously, the look of the cart and made it easier to use, first of all. But we also gave the arms a little bit more reach. And that allowed surgeons to do more procedures that required a larger work volume. And so we started expanding our clinical applications. Again, it's this need of affecting technique and, you know, expanding clinical application. And that's exactly what happened with the S. And then in 2009, we launched the SI, which was streamlined integrated. And although the robot looks the same, it was a massive architectural change that happened at that time. And what we did was change the surgeon console mainly, and basically modernized it, put in LCD displays instead of big vacuum tube TVs and so forth. And we also allowed for dual console, because I said there's 4 arms. But in open surgery, you often have a cohort. You have somebody else sitting there with that other arm. So we allowed 2 surgeons to operate the robot at the same time with the Da Vinci SI, which was a huge architectural change. And it also offered us sort of a scalable possibilities for other modalities, like adding advancements to imaging. And I'm going to get into some of these later, but Firefly, or allowing fluorescence imaging in our system. We have single site capabilities that started on the SI platform, as well as simulation and advanced instrumentation like vessel sealing and stapling. So we were able to really start adding more and more technology to our system. And then finally, we land on the XI system. And one thing I'd like to point out is there's a fundamental difference to the patient-side cart on the XI. If you look at these other three systems, it's a column with SCARA arms mounted to it. And so you're dependent upon where that column is. Now this robot isn't small, you saw it. This is like a 6-foot robot, the older ones weighed maybe like 900 pounds, the new one weighs 1,800 pounds. That is a large piece of equipment that can be in your way. And the beautiful thing about the XI system is it sort of takes into account sort of a ceiling mounted capability. It sort of gets the cart out of the way because the arms are all mounted on this boom that can be positioned over the patient in any which way you want. So it really offers a ton of flexibility to the OR team and to the surgeons. And we also increase the range of motion not only of the instruments, again, but also of the arms themselves. So we can really achieve multi-quadrant access through fewer ports. On the SI system, if you wanted to achieve the same thing, you kind of had to undock, put another port, move the whole robot over, and so forth. This really streamlines the workflow with the XI system. And in the year that we've had it, people are really using it and pushing the capabilities, and it's quite exciting. We have the same sort of modular architecture that's allowing us to expand technologies. So we still have the fluorescence imaging, the advanced instrumentation, that integrated energy that I spoke of. And our vision now is actually quite interesting. It's a chip-on-a-tip technology. So our whole cameras went from, you probably can't see it, but it's this large kind of heavy thing to this little tiny, that's not even the camera up there. It's actually, the camera's about this big, and it's at the end of the endoscope. And it offers 1080p resolution, 3D HD, again, channel on each eye. I hope that you'll find that the vision is quite phenomenal. And so that's our evolution and our products, and we're really proud of them. And but why? What, like what's the point? What's our value statement, if you will? And a lot of times you'll hear in medicine, first do no harm. People think that's actually part of the Hippocratic Oath, but it's not. And the real quote is, practice two things in your dealings with disease, either help or do not harm the patient. So basically, do what you go in there to do and make sure you get it done, or don't do it at all. And when you're doing it, try to not affect healthy tissue. You want to stay away from something that's not diseased. You just want to go in there and fix the problem. And this is a very old quote. This actually comes from, like, what is it, the book of the Hippocratic School way back whenever. But it's, first do no harm is kind of the idea. And it really goes into our value. Our value statement is an equation, because that's kind of the way that we think about things. But we put the patient first, always. And they're our number one stakeholder in the company. And we say, patient value equals efficacy, meaning like go in there and do what you intended to do, over invasiveness, do no harm, right? And when we first presented this equation, I think it was at a sales meeting probably 10 or 15 years ago, a surgeon stood up and said, actually, it's invasiveness squared. It's really important to do no harm, okay? The future of surgery is miniaturizing the effect that you have on healthy tissue. And it's true, and patients see this value as well. So on this chart here, along the x-axis, I have invasiveness, and on the y-axis, efficacy. And on one end of that spectrum, you'll see we have open surgery. You're cutting somebody from stem to stern. That's very invasive. But it's very effective. You're going to exactly get to the point that you need to get to. You're going to cut out your diseased tissue. You're going to sew up the patient. On the other end of that spectrum, you're not cutting the patient open at all. Maybe you're doing radiation. Maybe you're doing some other sort of alternative therapy. But is it effective? Are you actually cutting out that cancer? Are you sewing up that hole? And so laparoscopic surgery, or minimally invasive surgery, kind of falls in between, in that it's much less invasive than open surgery. It's effective because you're still cutting it out. And robotic surgery is on par with laparoscopic surgery in terms of the invasiveness, but we believe, and some of the literature shows, that we are more effective, and we're definitely more effective at hitting more complicated procedures that require more precision, more dexterity, and control. And so this is our value statement, and you can go on and sort of see, like, if I had an open surgery, this could be what my incision might look like, right? That does not look comfortable. And open surgery is, it has increased hospital stay. It has increased time of recovery. increased pain medication, increased blood loss, increased complications. These are all things that you don't want. That's not going to return you to your quality of life faster. It's actually a really huge cost to society. The surgery itself might be inexpensive, but the cost of the complications and what happens to somebody that having gone open surgery is actually quite large. And you contrast that with minimally invasive surgery, where you sort of just end up with maybe 3 little holes and some Band-Aids at the end of the day. That's the value of minimally invasive surgery, where it has definitely been shown over the last 2 decades to reduce trauma. But it hasn't been widely adopted, laparoscopic minimally invasive surgery, because complex procedures are hard to achieve. It's hard with straight sticks that have no wrists and you're looking in 2-dimensional vision somewhere else in the room to attack the cancers, to go after cardiac surgery, to go after places that are hard to reach or require high precision. And that's where we feel the robot really comes into play. And so what kind of procedures do we do? People ask us this all the time because you think of a robot and you think of surgery and you think, well, maybe it's doing orthopedics or maybe it's doing eye surgery. And there are some robots that are out there that help in those fields. But our robot is an extension of the surgeon's hands for soft tissue surgery. And so we work in the chest, in the thoracic. We have indications in thoracic surgery where we can operate on somebody's lung. In general surgery, which is really taken off with the XI system because you can see how large that area is that you have to reach. So colorectal surgery, upper abdominal surgeries, cholecystectomies, or that's gallbladder surgery, are all done using the robot. And urology, which is really where we kind of started, and with prostatectomies. And in fact, when prostatectomies were done laparoscopically 20 years ago, there was maybe 6, maybe 12 surgeons in the world that could do that procedure laparoscopically. That's how difficult this procedure was to do minimally invasively. And now, with the advent of the robot, there isn't a urologist out there who's still in business that doesn't do it robotically, or at least refer somebody to do it robotically. We have 85% of all prostatectomies now are done robotically. And that means that patient's getting a minimally invasive procedure. Partial nephrectomies, so kidneys, bladder surgery, ureter surgery, you name it, we kind of touch it. We also are indicated for head and neck surgery, so going through the patient's mouth and going at the soft tissue in the base of tongue for benign conditions. Otherwise, people kind of splay their whole head open, and that's really maximally invasive. So we're really, really proud of being able to help that out. And in cardiac surgery, again, instead of cracking somebody's chest open, you can go in through the ribs and have visualization to access things like the mitral valve or do revascularization procedures. And lastly, in gynecology, it's another really big growth area for us with hysterectomy, both benign and cancerous, as well as sacrocolpopexy, myomectomies, endometrial resections. And I can tell you what those are if you want, but really the point is we just can touch a lot of tissue and impact a lot of procedures. So people ask, well, what procedure does the robot do? And I kind of want to say, well, how long do you have? Because I can tell you all sorts of different procedures that the robot can do. So the other part that I was asked to talk about here is what is it like to work for a company like Intuitive? You know, working in this MedTech intersection or continuum, like I like to say. And it's really exciting. We are a very multidisciplinary company, and product development at Intuitive is no different. And we not only have engineering in every field of engineering with our mechanical, electrical, computer, vision, you name it. I'm sure we have some disciplinary and engineering there. But we have this whole huge group of user-facing components that go into our product development. So we have a human factors group, and they are responsible for basically understanding if I'm the user and I'm how easy is it to use the robot. They work with our interaction and our industrial designers to kind of make sure that the robot's easy to use, because you can have the coolest technology in the world, but if nobody knows how to use it, then that's not useful. And so we've really invested a lot of time and energy in making the robot, because it's a very complicated piece of equipment, less complicated. And then we, of course, have product marketing who help influence input needs. And then we have clinical development engineering, which is where my group is. And I wanted to talk a little bit about that because from what I understand, it's a pretty unique role. I came straight from academia into this job, so I didn't know it was as unique as it was until I've been kind of asking around, and I don't really see this role in too many other companies. We are the translators between the surgeons that use our product, maybe sometimes the patients that receive the care from our product, but mainly the surgeons that use it and the designers that develop it. And we have to speak those two worlds between engineering and the surgeons, marketing. We have to understand what they need and where they think the markets are. And we also have to pay attention to quality and any sort of complications that arise, or making sure that we meet quality standards as it goes out the door. On that note, we work with the regulatory agencies, and we're responsible for all the validation of the product. We work with training, because again, if you can't figure out how to use it or teach somebody else how to use it, then what's the point? And all that together, bucketed together, is what clinical engineering impacts at Intuitive. And it's our job at the end of the day to make sure that anything that comes out of Intuitive's doors is safe and it's effective. You know, and it goes right back to those two principles of medicine, that you got to be sure that you do what you went in there to do, and you don't harm somebody when you're doing it. And I really take a lot of pride in this, but that is what we do when we're developing procedures. So we work with a lot of our surgeons on getting them to optimize the system. It's a complicated system in order to do the procedures that they want to do and keep that cycle going between medicine and technology. So how do we develop things at Intuitive? There's a whole host of ways or approaches I could go about this, but I like to talk about achieving intuitiveness, because that's sort of the thing. And again, I really hope you get to demo and feel this for yourself. But we design with anthropomorphic principles in mind. And what does that mean? That basically means that we design our hardware to mimic the human operator. The robot can't do anything more physically, really, than what the surgeon can do, because that wouldn't be intuitive. If you could flip your head around 360 degrees, then that would be a little disorienting. So, you know, although our scope does have a big range of motion, that was a bad example. But the arms, really, we call them arms. And the arms have wrists, and they have shoulders, and that's what we call them. And we really try to make it very easy to understand. And we limit our range of motion and our torques and everything on the system so that it is similar to our goal of achieving what a natural feeling of what open surgery is. Because our goal is to give a surgeon that comfort and the effectiveness of open surgery, but in a minimally invasive setting. But again, we're trying to kind of go beyond what you can physically do. So the anthropomorphic principle works for the instrumentation and maybe the range of motion and stuff like that. But on the back of our business cards, like I said, our motto is that we're taking surgery beyond the limits of the human hand. So what other features do we offer that help with that? Well, the first is simulation. We've developed technologies with a couple of partners in order to really get people to understand how to use this console, because that's really the brains of the whole system, and that's foreign. We're taking a surgeon away from where they're comfortable on the bedside, being in control of their ship, to sitting down comfortable and being in control of the ship from there. So we really wanted to develop surgical simulation platforms to teach them very effectively how to use the system. And a lot of hospitals love this because they use it as a credentialing in order to grade surgeons, to make sure that they're at a certain point where they're then allowed to use the robot in surgeries and so forth. And the part that I love about the simulator is that surgeons use it to warm up before surgery. And that makes all the sense in the world. I mean, you're going to go out and play sports, you're going to warm up, or you're going to do something, you're going to warm up before you do it. If you're about to operate on somebody, I think I'd want to know that my surgeon had warmed up and they weren't coming in cold or hadn't had their coffee yet or whatever it is. So the simulation is really great, and it really helps us achieve that, taking limits beyond value. Another one is visualization. And so I have a personal belief that the future of surgery is just going to be miniaturizing that whole. You know, it's going to making things less and less and less invasive on the kind of making the incision front. And it's going to increase the capability of interventional radiology, or the ability to see things. And those two worlds are kind of coming together at a rapid pace. And the first technology that we have available is something that we've called Firefly. And what it is we can inject a fluorophore, it's called ICG, into the patient. It just goes into their bloodstream. It's actually very safe. It's been around for like 70 years. Kodak actually developed it. But it binds to blood proteins. So it binds to albumin in your blood, and it allows the surgeon to see where that blood goes. And so what happens is, on our system right here, we had added a laser, and so we can excite that fluorophore. It'll emit a photon. It's in the near-infrared spectrum, so we can't see it, but our software can pick it up and show it to the surgeon in a falsely colored way, so we can see things like vessels, blood flow, tissue perfusion, and it happens to be taken up by the liver, so then we can also see biliary anatomy. And it's really cool. And here's an example of what, I don't have very many gory pictures. I think this is the only one. But this is a picture of a kidney. And this is a picture of a tumor on a kidney. And it turns out that this fluorophore also binds to a protein in healthy kidney tissue. So what we can use fluorescence imaging for is to go into the fluorescence imaging mode and see what's healthy and what's not. So green is good in this picture, and what's gray is the tumor. And it gives the surgeon confidence when they're cutting out that tumor that they're getting, I always get this backwards, negative margins. You don't want the cancer tissue in stuff that you cut out. And so this is one of the applications for fluorescence imaging that's really taken off and helped surgeons make better decisions on the fly in the procedures. And lastly, we have single-site surgery, which is what it sounds like. It's putting all of your instruments through one hole. And if you imagine a bunch of straight instruments, even though they have wrists, going through one hole, you're basically going to be operating like this. And so what we had to do is make flexible instruments and curved cannulas so that we can maintain triangulation. And that's what this picture is showing here. This is this one point that's entering the body, but we are able to splay out our arms and put flexible instruments on the system and allow, because we have a computer in the system, to flip everything so it's intuitive. So the instrument I see on the right side of the screen is controlled by my right hand. The instrument I see on the left side of the screen is controlled by my left hand. If any of you are familiar with single-site surgery, that's the #1 problem with laparoscopic single-site surgery is you're basically operating like this. And it's very disorienting. And the patient value is that you just get this little tiny hole in your belly button at the end of the day. And it really is a scarless surgery procedure, and a lot of patients are asking for it, particularly for simple indications. So all of this together, what is the impact that Da Vinci surgery has had over the last 16 years that we've had product out there? Well, we have over 3,200 robotic systems worldwide, and that's across all 4 platforms. So the very early one that I showed you to the most recent one. And we do a lot of procedures with those robots. Last year we did a little over 500,000 procedures in 1 year. And the impact of that is that we've done over 2.5 million procedures in 16 years. And I bet most of you know somebody that has either had Da Vinci surgery, and if you haven't, you can see that my picture's up there because I had Da Vinci surgery about 5 years ago. And it's a testimony to say that I believed in our product well enough to go and have it done on myself for a procedure that I needed done. And actually 2 family members as well have also had Da Vinci surgery. So that's our impact. And I'll close with, yes, there's an intersection of medicine and technology, but I do like to say it's a continuum, and it's constantly evolving. And I guess at this point, I'll take questions. And if I don't answer any of your questions, you can always email our CorpCom email address up here. Thank you for your attention.
Hi, I'm just wondering, do you collect and then analyze the data that you get from your robot, like learning experience from your robot, really? Because that becomes a professional in itself.
That's an excellent question. So what do we do with the data? Well, first of all, do we get data off the robot is the first question, and then what do we do with it? And the question is yes and sort of. So the robot has a lot of data collecting capability. We've recently had it networked, and hospitals can sign a form and say, yes, you are connected. It's called on-site, and it actually really helps us with diagnostics, so we can kind of check in on that robot and say, oh, I got a message that an arm needs tuning or something like that. And so that's mostly what we do with the data is diagnostic checks. We do collect a whole bunch of other data with it for research and just kind of understanding and development programs, but I think we're still figuring out what to do with all that. I kind of heard that. Is there training required with the robot? Was that the question? The training is, so we are a device company, like most of you work for, and we're not a medical institution. So we have training facilities all throughout the world, but what we're doing is we're training people how to use the robot. And we assume that surgeons know how to do surgery, and we teach them how to use the robot, and they kind of need to put the two together. Hospitals, the onus of training is on the hospitals, and hospitals have a credentialing system that they use to determine what does it take for them to allow a surgeon to have the right to operate with the robot. And we help hospitals kind of come up with what that pathway might look like, but the onus is on the hospital to decide what the training is. But we offer all sorts of training, beginner training, advanced training, again, and we have several training centers throughout the world. Yes?
I was just wondering,
How do hospitals look at the return on investment? That's a pretty complicated question that I don't think I can give you a great answer for. There's Da Vinci economics and all this stuff, but I'm an engineer, so they don't let me do that stuff. So I would refer you to Erica in the back of the room. She's sitting here. She will talk to anyone at the demo if you want to know financial stuff. Yes?
Can you do remote surgery?
Can you do remote surgery? That's an excellent question. So theoretically, yes, you can do telepresence. You could put the surgeon console in one room and have the robot in another room. We have a 100-meter cable, fiber optic cable that connects the two. And in fact, there's one hospital in Florida that actually does that because the surgeon likes to go really fast between two rooms and operate at the same time. And it's like, okay, you can do that. But your real question is, can we do like transcontinental or transatlantic surgery? And the answer is someday, hopefully. We can't do it now. There's a delay, and you don't want any delay in surgery, so there's a slight technical limitation. And there's also, ironically, a legal thing. If the surgeon's here and the patient's there and something goes wrong, whose responsibility is it? So that's something to be tackled by probably somebody other than us, but that's the answer. Yeah? Yes? Is it Wi-Fi? That would be amazing to not have all those cables. There are so many cables on the floor of an operating room. It's unbelievable that people don't break their ankles on a regular basis. No, it is not a wireless system right now. It is fiber optic connected. But if you all can figure out a way to make a wireless endoscope, that's the first thing that I would like. Do we give the surgeon tactile feedback? That's a question that we get a lot. And the answer is we don't have tactile feedback, but we do have haptic feedback. When you are sitting at the console, and you may or may not experience this depending on if you decide to do rock'em sock'em robots out there, but if you're trying to move the instrument somewhere where it can't go, then you're going to feel that. You're going to feel like, hey, I'm trying to move it, and it's not, the motors aren't allowing my instrument tip to go somewhere. Can I feel textures? Can I feel pulses? No, I don't have tactile feedback. But what we've learned from our surgeons is pretty quickly on, surgeons count on their visualization for their haptics. And it's pretty amazing. And I mean, you can do the same thing. I mean, I could tell you from there, if I poke on myself light or hard, you can see just from the indentation on my arm if I'm doing it light or hard. And so people really develop a whole skill on learning their tactile feedback through their eyes.
Are surgeries performed with the robot? Can a hospital charge more for performing surgery with the robot versus surgery without?
That's a great question, and I think hospitals can charge whatever they want. I don't think that they're going to do very well if they do that. The insurance isn't going to pay them any more for using the robot versus not, because it's still laparoscopic surgery. We do have some, what's the word? It's the same reimbursement as laparoscopic. We don't have our own code for robotic surgery, so it's not wise for the hospital economically to charge more for the robot. Do I have a roadmap to what? To cardiac bypass surgery? We do cardiac bypass surgery. It is called revascularization, and it's pretty neat. You can go in, you take the IMA, the vessel that's inside your chest, down, and you use that as your bypass, and you reconnect it up to the coronary artery on the surface of the heart. And we have actually we do it with beating heart, so the patient doesn't need to go on bypass. There's an instrument that we developed that's called a stabilizer. Thanks, Ray. That is a little suction kind of instrument that goes on top of the heart, and it basically makes that area that you're operating on stable. So we do bypass surgery. Okay, one more question, I guess, and then we'll hit the demo. Wait, you've already asked one. I'm going to give somebody else a chance. All right. I'll answer it after.
I had a question. Can there be some pre-programmed motion? So can it, like a staple gun, you say, give me staples, give me knots from here to here, and rather than have the surgeon tie every loop and every knot, it just kind of point and clicks and say, give me a knot here, give me a knot there.
Sure, sure. So really what you're getting around is, do we have any autonomous motions with the robot? And the answer is absolutely not. And I would not want there to be. Surgery is incredibly dynamic and changing, and tissues change in a moment, and the patient's stability and vitals change in a moment. And so, I mean, could we? Sure. Do we? No. And I don't think we will. I think you really want the surgeon in the loop making those decisions. Now, having said that, like our stapler instrument does have some smart technology associated with it. And when you're stapling tissue's viscoelastic, so you need to compress it long enough and hard enough to squish out all of the tissue, all of the fluid, so that when you staple, you're stapling right on tissue. And so we actually have something called smart clamp technology that no other laparoscopic stapler has, where we literally sit there and we know, because we have sensors everywhere, we know exactly when the jaws are at the optimal position where the staples are going to actually do their best functioning. And so we do stuff like that, but we don't do like, okay, I'm going to go take a coffee break, you go suture up this incision for me. But some surgeons have asked for that. You laugh, but people ask for that. But I don't think we'll be doing that anytime soon. All right, well, thank you again for your attention. This was a lot of fun. And again, I hope you enjoy the baby in the back.